Hello viewers on YouTube. In this video tutorial, we are going to focus on how to partially differentiate a function of a function in relation to multivariate function. For those who learned derivative, then you should know what a function of a function is. But perhaps for those who might be hearing that for the first time, here's what I'm saying next is. For a univariate function in differentiation, an example of a function is y equal to x squared plus 2 all to the power of 3. This is an example of a function in relation to a univariate function. But in the class of multivariate function, an example of a function is z, because we use z this time around, because z would be in terms of x and y. Z is equal to x squared plus 2y all to the power of 3. So this is a function of a function in relation to a univariate function, and this is a function of a function in relation to multivariate function. Now, the purpose of this video is to show you how you can differentiate a function of a function in relation to multivariate function. So, what do you need to know? Let's talk about that. To differentiate a multivariate function, that is a function of a function, if z is equal to k of x comma y, that's a function of a function, all to the power of n, where n can be any real number, then the partial derivative of z with respect to x is simply equal to n multiplied by k of x comma y to the power of, reduce the index by 1. So now we have to the power of n minus 1. Then you have to multiply it with the partial derivative of k with respect to x. Likewise, if you are differentiating partially with respect to y, then this would be almost the same as that of x, but these to be different. So you should know what that is going to be. So that will be n multiplied by k of x comma y all to the power of n minus 1, and then multiply by the k the y. So these are the formulas that can guide you in order to successfully differentiate a multivariate function partially with respect to any of the independent variables. Now, to put this into good use, let's consider some examples problem. Example number 1. Consider the multivariate function z that is equal to x to the power of 3 plus 7y squared all raised to the power of 4. So how do we find the partial derivative of z with respect to x? Well, before we proceed on this, let's identify what our k of x comma y is. Well, that is simply the inside function, which means in this case, that will be equal to x to the power of 3 plus 7y squared. So now, let's find the partial derivative of k with respect to x, which is k sub x, or in other words, die k die x. Remember, from the techniques of differentiating a multivariate function partially with respect to a certain independent variable, then the other independent variable must be treated as a constant, which means in this case, since we are differentiating partially with respect to x, then y must be treated as a constant. And so therefore, that k that x will simply be equal to 3x squared, as this will become 0, since there is no x term attached to it. Likewise, our k sub y, which is the same as that k that y, will be equal to 14y. This becomes a constant and becomes 0 because the derivative of a constant is 0. The derivative of 7y squared is simply 14y. Excellent. Now with this, we can proceed on finding the partial derivative of z with respect to x. As we know that according to the formula we stated earlier, that will be, if this is our n, that will be 4 multiplied by the function itself, x cubed plus 7y squared, all to the power of 4 reduced by 1, which is simply 3. Then multiply by k sub x, which is 3x squared. And then we have times 3x all to the power of 3. Now simplifying this to a least form, we have the product of 4 and 3x squared to be 12x squared. And we have this to be multiplied by x cubed plus 7y squared all to the power of 3. And that gives us our final answer to z sub x. Likewise, z sub y. For z sub y, that would be almost the same as this, but the difference is that instead of having this, we would have this. So what I'm going to do is I'm just going to write this straightforward, as that will be 4 multiplied by x to the power of 3 plus 7y squared all to the power of 3, then multiply by k that y, which is 14y, and I have times 14y. Hence, this will give us the product of 4 and 14 is simply 56. Then we have y, and this will multiply by x to the power of 3 plus 7y squared all to the power of 3. That gives us the result to z sub y. And guys, this is how you can partially differentiate a function of a function in relation to a multivariate function. So let's consider example number 2. By the way, feel free to try this out for you to just see if you are following. Also, if you are yet to subscribe to the channel, feel free to subscribe. So consider the function z that is equal to 3x to the power of 2 minus 1 over 2y all to the power of 3, then all is to the power of 5 over 4. So how do we find the partial derivative of z with respect to x and the partial derivative of z with respect to y? Well, I changed my mind. This will be an exercise for you. So feel free to put this into good use by providing the solution to it. Likewise, you can share your solution with me via the comment section below. Thanks for watching once again. Bye for now.